question number 1 has two parts. First, we have to identify the segment bisector. Bisector means the thing that cuts something else into two equal pieces. So we can see that this line segment is being cut in half by that right there. So we have the bisector of xy can be either M, which is the point right there where the two intersect, or you could write the ray MN, and we've got to have the ray symbol up above it. So those are two options for that question. The length of xy can be found by setting up the equation 3x plus 1 equals 8x minus 24. We know that those two parts are equal because this symbol right here and here means that this segment is equal to that segment. Once we solve for x in this equation, then we can plug it back in and find the length of our segments and add them together. So we can do this by subtracting 3x from both sides. We end up with 1 equals 5x minus 24. Then we're going to add 24 to both sides. Add 24, we end up with 25 equals 5x. Finish this out by dividing by 5. And we end up with x equals 5. Now we've got to plug this in to these two line segments, so x will go there, and if we did it right, then those two things should give us the same measure. So we end up with 3 times 5 plus 1. 3 times 5 is 15, so we get a total of 16 for that line segment right there. And again, as I said, if we did it right, then the other one should also be 16. So we have 8 times 5 minus 24. 8 times 5 is 40 minus 24. And 40 minus 24 gets us 16. So indeed, we did do it right. So we've got 16 for this segment, 16 for that segment, for a total segment length of 32 from x to y. So that would be our answer for the length of xy, is 32 units. On our next question, we have the same tasks, segment bisector. Again, we have a point called M where they intersect there, so that is one option. This line is also a possible bisector, so we could say line L is a bisector for that as well. So again, we have a couple of different options for that one. And to find the length of JK, we're going to do what we did before. This segment on the left is the same length as this one on the right. So setting up an equation, we can say 3x plus 15 equals 8x plus 25. And we'll solve this for x like we did before. We end up with 15 equals 5x plus 25. Subtract 25 here. And we end up with negative 10 equals 5x. Finish this out by dividing by 5 to find our x value of 2. And we're going to plug that x value into here, and again, if we did it right, our two segments should have the same length. So we get 3, and I messed up here. This is a negative 2. We have a positive divided by negative right here. That will make a difference. So we have 3 times negative 2 plus 15. 3 times negative 2 is negative 6. Add those together and we get 9 for that segment right there. Well, let's test it out in our other side over here. We end up with 8 times negative 2 plus 25. 8 times negative 2 is negative 16. And negative 16 plus 25 again is 9. So we end up with 9 and 9, which means we did it correctly. Putting those together, we have a total segment length JK of 18 units. That's 9 plus 9. On this one right here, we have to see if the line segment AB is congruent to the line segment CD. So we're going to graph these points right here. 8, negative 4 will be that point. That's A. 3, negative 4 will be that point. That's B. So we go from here to here, and we can see that's 5 units in length. CD would be these 2 points right here. We end up with 7, 1, which is right there, and 7, negative 3, which is right there. So that line segment right there has a length of 4 units. In order to be congruent, they need to be the same length, so they are not congruent. And we know because they are not the same length. That is our answer for this part. Not the same length. Next question is the same question where we're seeing if they're congruent. So let's graph AB. 6, -8 will be right here. And 2, 1 will be right there. So we have a diagonal line this time. And then CD is from 7, -2 to -2, +2, right there. So we've got these two. Now the diagonal lines, we're going to use our rise and our run, and we could use the Pythagorean theorem to find the length. So we're going up and we're going to the left on this one, from here to here, or you could go right and down. We end up going up 4, and we go to the left by 9. And then let's do the same thing with this line segment right there. So we're going down by a total of 9, and we're going to the right by a total of 4. So these two have triangles that their legs are the exact same length. If we did the Pythagorean theorem, we could find out the exact length, but we don't actually need to do that today. We can see that when the legs are the same, then this third side is going to be the same, because we'll end up with the same numbers in the Pythagorean theorem either way. And since our question is just if they are congruent or not, we can tell that they are without actually computing that length. And the answer for our reasoning is the lines are the same length. Alrighty, for the next one we've got points JK and we have to find the midpoint. So we have 7, 1, that's right here, and we have 2, -5, that's right there. So to find the midpoint, we're going to see how far we go up and over, and we're just going to cut that in half. So we're going up and to the right. From -5 to 1 we go up by 6, and from 2 to 7 we go over by a total of 5 units. So we cut that in half, and we're going to have to go up by 3 units and over by 2.5 units to get where we're going if we go from here, or we could go from the other end and reverse that direction. So if we go up 3 units from here, that puts us at a y value of -2. And if we go to the right by 2.5 units, we end up at an x value of 4.5. If we go the other direction and go left and down, we end up at the same point of 4.5 and -2. So that is our midpoint. Alright, now we're going to find the distance from J to K. Here we need to use the Pythagorean theorem or the distance formula. Those are variations of the same thing. So Pythagorean theorem is a squared plus b squared equals c squared, and our legs have units of 6, so we get 6 squared, and 5, so we get 5 squared, equals c squared. 6 squared is 36, 5 squared is 25, and we're going to add those together. 36 plus 25 is 61. And to finish this out, we're going to take the square root of both sides. Square root of 61 is not a nice number, so you could leave it as the square root like that, just write it as square root of 61. Or you could plug it into the calculator and write it in decimal form, rounded. If we do that, we end up with a total of 7.8. Now we need to find the midpoint again. L is at -3, 5, so that would be right here. And N is at 8, -1 over there. So we're going to go from end to end like we did before, and then we're going to cut it in half. So we're going to the right, we're going down. To the right we end up going 11 spaces, and we go down by a total of 6. So when we're cutting that in half, we're going to end up going over by 5.5 spaces, and we're going to go down by 3. If we go over by 5.5, that puts us at a total of 2.5 for our x. And if we go down by 3, that puts us at a value of 2 for our y. So that is our midpoint at 2.5 and 2. That puts us right there in the middle of that. Finding the distance from L to N, we are going to use the Pythagorean theorem again. So we have 11 and 6 as our legs, so a squared plus b squared equals c squared again. That would be 11 squared plus 6 squared equals c squared. Doing those calculations, we end up with 121 plus 36 equals c squared. Add that together and we get 157 equals c squared. Finish this out by taking the square root of both sides. We end up with c equals 12.5 if we round it into decimal form, but again, you could leave that as the square root of 157 if you prefer. On this next question, we are given a midpoint and one endpoint of a line segment. We need to find the coordinates of the other endpoint. So if we were to graph these, the midpoint of 6 and 3, that would put us right here. And then 14.9 for the endpoint. 14.9 would be right there. And we'll label those J and M. Now I want to have those labels this time because I need to know that my other endpoint is going to be somewhere down here instead of up there. And I can tell that because that point should be in the middle and J should be on the end. So a common mistake is to go the wrong direction with this one. So I like having those labels there. Alright, our strategy on this one will be to figure out how far we go down and over, and then to duplicate that and find the other end. So if we go from J to M, we end up going down by 6, and we end up going to the left by 8. And if we're going to find the other point, we need to go down by 6 again, and to the left by 8. So down by 6 would put us down here at -3, and if we go to the left 8, that would put us over here at -2, and we can see that we are duplicating that distance over here. So the coordinates of that were at -2 for our x and -3 for our y value. That's our other endpoint. On this question, our goal is to find the distance from home plate to second base. And on a baseball diamond right here, that creates a nice right triangle. It's a square, and we can see our right triangle right there if we draw that line from home base to second plate. We know the dimensions of a baseball diamond are 90 feet in between the bases. That's shown in the word problem right there. So we can use the Pythagorean Theorem to calculate the distance from home plate to second base. So again, a squared plus b squared equals c squared would give us 90 squared plus 90 squared equals c squared. 90 squared gives us 8100, so we end up with 8100 plus 8100 for this calculation. Add those together and we get 16,200 equals c squared. Finish this out by taking the square root of both sides, and we end up with a measure of 127.3. That, of course, is a rounded version of the decimal for our c. And the units on this one are feet. So that's going to be 127.3 feet. And here, find the distance from the between home plate and the pitching mound. We can use this information here that the pitching mound is the midpoint between home base and second plate. So we know that the distance all the way to second base is 127.3 feet. And if we have the midpoint for from here to here, then we end up just having to divide that by 2. So 127.3 divided in half ends up getting us 63.65, which of course that's rounded as well because this 127.3 was rounded. So our answer for that one is 63.65 feet. For this question, we need to calculate the perimeter of a polygon. We're given the vertices, but we need to find the lengths of each of the edges in order to add them together for our perimeter. So we're going to graph those vertices. It's at -1, 0, then 1, 2, 6, -3, and 4, -5. Gives us these 4 vertices right here. 1, 2, 3, 4. And we need to calculate the perimeter, so we're going to draw right triangles outside here. This one on the top left has edges of 2 and 2. So that will give us 2 squared plus 2 squared equals c squared for our Pythagorean theorem. 4 plus 4 equals 8. So we end up with 8 equals c squared. Finish this out by taking the square root of both of those sides, and we end up with c equals 2.8. So this edge has a measure of 2.8. On this next one, draw our right triangle there and there. We end up with 5 and 5 for our edges. So Pythagorean Theorem tells us to do 5 squared plus 5 squared equals c squared. That's 25 and 25 for a total of 50 equals c squared. Take the square root of both those sides, we end up with c equals 7.1. So our second edge has a measure of 7.1. The bottom right one here has a right triangle with sides of 2 and 2. I don't need to repeat that calculation. I've already done that right triangle with the top left one. So I'm just going to take that measurement of 2.8 and put it here. And we can see on this last triangle right here we have a 5 and 5 like we did on the top right triangle. So we don't need to repeat that either. This gives us a measure of 7.1 on that edge. So we now have the measures of all 4 edges of our right triangle, and we can add them up. So we end up with 2.8, 7.1, 2.8, 7.1. Add those all up, and we get 19.8. I don't know the exact units, so I'm just going to write units, and that is our perimeter for this first one. On the second one, our vertices are negative 6, 2, negative 6, 8, and 5, 8. So this gives us a triangle that looks like that. And we can see it's a right triangle with the right angle over here. And the edges right here on the left and the top are vertical and horizontal, so we don't even have to do anything except count for those. The left edge has a measure of 6, and the top edge has a measure of 11. And since it's already a right triangle, that gives us the edges to find this third side as well using the Pythagorean theorem. So we end up with 6 squared plus 11 squared equals c squared. That'll give us 36 and 121 for a total of 157 equals c squared. Taking the square root of that, we end up with c equals 12.5, and that's 12.5 units. On this next question, we have the same polygon that we had before. We can see our vertices at negative 1, 0, 1, 2, 6, negative 3, and 4, negative 5 down there. But this question asks us to calculate the area instead of the perimeter. Now, in our previous work on this, we saw that we had 2 and 2 for a slope of 2 over 2 on that one. And we had 5 and going down 5 for a slope of 5 over negative 5. The slope here is 1, slope here is negative 1. Those two slopes are perpendicular, so this is a rectangle. We also notice that the opposite edges are the same, so that supports what we just said. Area of a rectangle is pretty easy to compute. If I know the lengths of the sides, that's just area equals length times width. And we already know the length and width of those sides. We can see that here, where we have 2.8 and 7.1, and we can use those two measures as our length, 2.8, and our width, 7.1, and calculate that. So we end up with area equals 2.8 times 7.1. Doing that calculation, we get 19.88, and that is units squared, because we are measuring area. So make sure you write these square units on there. And finally, we have the same polygon, the triangle that we worked with before. And we saw that that was a right triangle, and we had the measurements of that as well. Right triangles, or triangles in general, have a area of 1/2 times base times height. The base and the height need to be perpendicular to each other, so the fact that this is a right triangle is very convenient. We can use these two edges right here and here as our base and our height. So we end up with area equals 1/2 times 6 times 11. Calculating that, we get 1/2 times 66, or an area of 33. And again, this is units squared. Thank you very much for watching, and good luck.